As far from land as possible is the question, and this is a classic multi-source BFS question. So the trick is to flip the question around. Instead of asking for each water cell how far is the nearest land, you push all land cells into a queue at once. Then you expand outward, one ring at a time, and the last water cell that you reach is the furthest one, and the number of rings you expanded is your answer. So I'll run you through the code line by line. Over here, we are getting the length of the grid, which is the dimensions, and it's a square grid. So one number will cover both the dimensions. Then declaring a deck, which is a double-ended queue, and then we are iterating, we are scanning through our grid. So for R in range, N, as I said, one dimension is enough because it's square, and for C in range. And then we are collecting the coordinates of all land cells into the queue. You are detecting the land cell by the number 1. And this is the multi-source part. So instead of one starting point, BFS begins from every piece of land at once. Now, if not Q or length of Q is equal to n times n, so these are your two failure cases from the problem statement itself. So if your not Q is true, when the deck is empty, meaning no land exists, so you can't even begin your multi-source BFS. And your length of Q equals to n times n means every cell is land, so there's no water to measure. Either way, you just return -1. Now you start with distance being -1 rather than 0 because the first pass of the loop processes the land cells themselves, which sit at distance 0. So the distance plus equals 1 over here at the top of that pass just bumps your -1 up to 0. So this like keeps your bookkeeping lines together. So you iterate until there are elements in the queue, distance plus equals 1, as I said. So each trip through this loop handles one complete ring of cells at the same distance. So this counter tracks how far out we have spread. Then a for loop. Now, your length of queue is evaluated once before the loop starts and capturing how many cells are currently in the ring. We then process exactly that many, and the cells appended during the loop belong to the next ring and get handled on the next while pass. And without this particular snapshot, the levels would blur together and distance would be meaningless. So then we start with popping the first element from the queue. So this is the oldest cell from the front. And then we set the direction. So up, right, left, and down for DRDC. Whatever we have popped, we add it to our direction. And then we call it the neighboring cell. This is the check that we do, which is that this is the bound check. And then we say that if we mark this as visited, so grid of this neighboring cell, we mark it as 1. So we turn it into land, and then we append it to our queue for the next ring, and we return our distance.